In this paper, we present scalable object detection in mixed reality using incremental retraining and one-shot 3D annotation. Though object detection is incredibly useful for applications like language learning or instruction, pre-trained object detection models cannot handle untrained objects in the user's environment. Classification architectures require manual labeling of many images for a new class, and they don't easily allow new classes to be added without significant retraining. To address this problem, we introduce a new approach to scalable object detection, which begins with a one-shot labeling process. This allows us to automatically generate a dataset of training images that are used to update a detection model on the fly with a process called incremental learning. Our approach allows users to quickly interact with newly added classes that would otherwise require significant manual labeling and complete model retraining. To select the correct object voxels, we provide two methods to create 3D bounding boxes. The first is point and scale, which uses the intersection of the control arrays to assign a center point. The user can then scale the box with a secondary selection and rotate it around the y-axis to match the target orientation. The second is called multi-point bounding, which allows the user to select individual corners to form the entire bounding box using raycasting. This provides more fine-grained control for each axis and is useful for nearby or smaller objects. Next, the user assigns a text label to the object, which also triggers the start of a dataset acquisition algorithm. Once the label is placed, any subsequent frames within the user's viewpoint that contain the target object are used to compute the corresponding 2D bounding box on the object from the current viewpoint, and then the corresponding image is saved in a list. Once an adequate number of images have been acquired, the data is sent to the REST API server to be added to the object detector using our incremental learning process. This framework allows the new dataset to be used to retrain a detection model with a majority of its layers frozen. By replaying a subset of exemplars from the old dataset along with the new class for training and validation, we can add the new class to the detector much more quickly than having to retrain the entire network. This end-to-end approach allows a new class to be used in practice, which can be seen here in the secondary language learning application that we implemented as a testbed. Note that prior classes retain their accuracy, allowing for scalable object detection in practice. We have also tested this with other objects to ensure it works across multiple classes. Here we see the scalability demonstrated with a larger number of objects and a diverse set of characteristics. With this new approach, we hope to enable the practical use of mixed reality applications such as language learning, factory assembly support, maintenance instruction, and other tools that rely on object detection for interaction.